Hello, I'm Les Gray, and this is just one of my Raleigh Wisp mopeds. I've been a member of the NACC Moped Club for a long time, and I've been riding these particular bikes now since I was 16, and have become quite an expert in the ins and outs of this particular machine, and the technicalities in managing to keep one on the road in good order and working properly. These machines were manufactured in around, I think it was 1967, this particular model, and in actual fact this particular machine was never any good, even when it was new. But let me tell you a little bit about it. Single cylinder engine, 50 cc's, 1.5 horsepower, belt driven to this device here, which rotates the back wheel and off you go. I think that's actually a 2 litre petrol tank, good for about 100 mile, at a top speed of 23 miles an hour. Now, as you would imagine, quite a few people come to me for technical advice on their machines, so I've decided to do these videos. I'm going to go through one of the, or certainly the major questions that I'm continually asked about the machine and how I manage to keep mine in the order that I do. So I'm now going to tell you about some of the problems and how to deal with them. Now, clearly, one thing you need before you embark on any moped maintenance is a good toolkit. With machines like this, of course, they're all imperial nuts and bolts, and it is quite old. So you need a particular set of tools, really, which you should carry with you on the machine as well. That's very important because they are quite unreliable. What I'm going to do then is I'm just going to run through those pieces of equipment to give you some idea of what you need to carry with you. So here we are, the basics of the Raleigh Wisp toolkit. Now, for those nuts that are quite stubborn, we've got an adjustable spanner, very useful piece of equipment, a series of screwdrivers necessary, and if these prove to be inadequate, there is some heavier screwdrivers.
The hammers they are, Liz.
Hammers?
The hammers they are, not screwdrivers.
This sort of equipment, this is a piston compressor. You might have thought we'd got this here for some sort of lifting up of the bike. Well, that would be ridiculous and unnecessary. But something of this sort is needed to compress the piston springs. Tool is particularly versatile. Not only can it be used to lever out the piston when you've got it to top dead centre, but it can also be used for adjusting the points, and you'll find that the points gap has to be set to suit that little bit of sliver of burr that's on the end of there. Right, well, I mean, a lot of these tools have multiple uses. I mean, this particular tool I find quite useful for breaking the links in the chain. It's a very good chain splitter. For the smaller chains on the bike, I would use this particular chain splitter. You need something with a bit of a finer blade on the front. Do be very careful with these tools because they are extremely sharp. Now, another piece of equipment, or a tool really, that is essential is an electrical test meter, which I've got here. And people are often asking me, because there are a lot of spark plug issues with these Raleigh Wisps, with spark plugs oiling up and becoming unserviceable. People often ask me how it is that I managed to keep my bike running so well. And the spark plugs don't last very long, which is part of the problem, and therefore it's very important that you're able to test one to see if it's in good condition. One thing we need to be sure of with our spark plugs is that we're getting a full 12 volt power out of them. This particular meter is very good for that. Now, to test the spark plug, we put the positive terminal on the cap of the spark plug like that, and we're looking for a full 12 volt output from this spark plug, and we're looking for the 12 volts between that terminal and the very bottom terminal there, and our meter will tell us whether this spark plug needs replacing or whether it's okay. So here we go, we'll just touch the terminals. Ah, yes, here we are. It's telling us that this particular spark plug needs to be replaced. It's probably only giving out about 3 volts, so we'll discard this particular plug, and we won't have any problems associated with it with our Moped. Now, this is another spark plug that I've got, and sometimes the condition of a plug can be deceiving as to its performance on the machine. You might notice that this is actually a short reach spark plug, but in actual fact a Raleigh Wisp is designed to run on either short reach or long reach, but if you do use a long reach spark plug, make sure you put plenty of washers underneath the plug before you install it. Now let's just demonstrate a point and work out what voltage is coming from this particular plug, and I'll just connect it now. Yes, yeah, that's a much better plug. As you can see, we're almost into the green for good, and there's a good few miles left in this particular spark plug yet, so this would be serviceable as it stands, although not perfect. There have been quite a few occurrences of catastrophic wheel failure with the Wisps, investigation has shown this to be failure of the spokes. One way to prevent this happening, because it's not always picked up on the MOT, is to check the spokes out individually. Now, what we have to do here is we have to check that each spoke individually isn't more than 25 amps. And this is done by connecting to the spoke with a meter. Come in a bit closer. Now, we get the meter, put the leads on, and what we do here, we're looking for 25 amps between that point there and the point where the spoke goes to the centre of the wheel there. And what happens is, if rust accumulates on the spoke and reduces the strength of the spoke, we can detect it with the electrical meter. Now, so as I said, you connect the clip there, and we're measuring the resistance of the spoke, and it must be at least 25 amps. And let's have a look at that one. Yes, that's a good one. Yeah, we know that that spoke is okay, and it's a matter of carefully, one by one, going round the wheel and checking that that's the case. If you do get any spokes that don't meet the 25 amps resistance rule, then the best thing to do is to remove that particular spoke to prevent it becoming a weak point. And the best thing to do is to cut the spoke out with a pair of pliers and just remove it and leave it out, and then that will remove that particular problem. I mean, it can be removed with a hacksaw as well as an alternative method of removal. But do make sure that, to be safe, you leave at least 2 spokes in the wheel. Now, other Raleigh Wisp moped riders have often asked me how it is that I managed to get my moped to ride so smoothly on the road. Because of course one of the problems with the Raleigh Wisp is there's no suspension front or back, and it can cause a lot of back troubles with the users that ride these mopeds. I've developed a way of eliminating that particular problem, and I'll show you what that is in a moment. I do want to show you one other important thing that you can do with these wheels and tyres. So to do that, first I'm going to remove the wheel from the bike to show you a couple of things associated with that. A lot of people have been filling their tyres with air and even nitrogen to get a better seal and ride quality, but in actual fact I've discovered that water makes a better job, and that is how I achieve such a smooth ride on my machine. I'm now going to demonstrate to you how we go about filling the tyre with water. Firstly, obviously we have to make sure that the tyre is flat. Doesn't have to be completely flat, but you know, let's say down to just 20% full. Right, the next thing we do is that we fill the pump with water, and for this I just use a bucket of very clean water and suck it up into the pump. Yeah, let's just check we've got a completely full pump. It does take a couple of times to just bleed the pump free of its air. Once you know the pump is completely full of water, we then attach the hose to the tyre. You can do this with a foot pump, submersed in a washing up bowl full of water, but I find the hand pump a little bit easier. Now, once the hose is securely fitted to the tyre, thus, you give it a good pump and get that water straight into the tyre. Thus.
And shouldn't the pump be in the water? Shouldn't the pump be in the bowl? It's more efficient.
In actual fact, as a colleague has just pointed out to me, it can be more efficient to actually put the pump in the water, rather like the foot pump method, and do it like this. There we are, we can hear the water going in now. Can you hear that? Once the tyre is up to pressure with water, then obviously we've completed the necessary task. It doesn't necessarily matter if there's a bit of an air pocket in these tyres and that you haven't managed to get them completely full, because these particular machines go that slow that the water always drains to the bottom of the tyre. And of course, as you'd expect, that increases the miles per gallon that you get out of the bike. One thing that is of course a problem with these particular machines is getting new tyres. This is always a difficulty because this particular size of tyre is no longer manufactured. So it's always desirable to be able to prolong the life of your tyres. And there's one or two methods that I adopt to achieve this. When a tyre becomes warm and smoothed over, the best thing to do is, rather than trying to get a new one or buy a second-hand one, which is very, very difficult, it's best to re-groove them. And I'm just going to demonstrate how this is achieved. I like to hold the tyre firm in the vise, off the bike for reasons which you'll see in a moment. I find the best thing to do to re-groove the tyre is to first go round the tyre with an ordinary wood plane and remove any bits of tread that have not worn off. that are remaining, say probably caused by a long skid where you've got a large bare patch and patches of bits of the tyre that have still got tread on, and these can be simply removed by shaving them off with an ordinary wood plane. Thus, when you've got the tyre completely even, so the tread is about the same depth all the way around, then we can move on to do the regrouping. And the best way of achieving this is, of course, with a good quality saw. What I've found is it doesn't matter too much if you don't stick exactly to the previous tread pattern that's on the tyre. In fact, indeed, you might not be able to see it, it could be that worn. So it is really just a matter of putting some random cuts into the tyre at intervals like this. Not too deep, of course, otherwise you'll get through to the inner tube. And any sort of cut of this nature will indeed improve the tread. One piece of advice I would give you regarding this technique, and I can vouch from this from personal experience, that it's best to have your moped MOT'd before you'd carry this out. You're probably wondering what this pipe is and how this may be relevant to a Raleigh Wisp moped wheel. But in actual fact, this is a very effective way of testing the wheel bearings. Best done when you've got the tyres off the machine. These bearings, of course, can be very temperamental.
Best done when you got.
For those of you that are fortunate enough to have a stethoscope, then that is the tool to use. But you can carry out the same test with a piece of gas rubber tubing. Now, what you have to do is place the rubber tubing on the bearing there and then rotate the spindle, and you'll be able to hear whether the surface of the bearings whether the surface of the bearings are rough or smooth by the grating noise. And I can hear that these particular bearings are probably near the end of their serviceable life. Braking efficiency has always been a cause for concern on these small mopeds, and here we have a couple of typical brake shoe examples. This one has a brake lining fitted to it, and this one has had the brake lining stripped off it, and you can see that it's been removed there. Now, amazingly, the metal to metal contact by using a brake shoe that's got no lining on it is actually superior when used on the moped to the one that's got a brake lining on. So I would recommend removal of the brake lining and just polishing up and cleaning the metal surface of the brake shoe like that. Be very careful because these are often asbestos. Once you've cleaned that up like that, you can either use a wire brush or a toilet brush, whichever gives you the best effect, and refit the shoes without the lining to your bike. There is a little bit of a drawback with this particular technique, and that is that it does wreck the hubs of your bike after about 20 miles. Performance of these machines is known to be drastically adversely affected by carbonising and resistance within the exhaust system, and some machines have been known to lose something like 1.5 miles per hour as a result of a blocked exhaust. Now, here we have a couple of typical exhausts. One of them apparently in good condition, and one of them apparently in poor condition on the external, but that is no indication of how blocked they are with carbon. There is a simple test to check for this suitability of the exhaust pipe called the horn blower test. What one does is simply blow in a deep voice into the pipe, and if the noise comes out as a high pitch, that pipe is good for use. If it comes out as a low pitch, then that pipe is blocked and really should be discarded or electrostatically cleaned. So let's see what we've got with these two exhaust pipes. I shall blow into this one first. So we're hoping for a high pitched sound from a good exhaust. Not much good. Perfect. This is the exhaust that we would fit, and it does look to me as if somebody has in the past refurbished this particular one.